Hey everyone, this is a tutorial with Travis. Today we're going to talk about the Cramer's rule. Before we get started, I just want to stress the positions in the matrix as A, B, and C, and D. And I'll show you real quick what I mean. The first element in the row and column would be A, first rows, second column, B, and so forth, C, and D, and so forth, and so on. It's a 2 by 2, by the way. Alright, so with the Cramer's rule, we're looking for the determinants. There's a total of 3 determinants that we have to solve for. So in order to do that, you have to actually solve for the first one, of course. And to do that, you have to multiply the A and the D and subtract it from, sorry about that, the A and the D and subtract it from C and B. A and D is multiplied together, and then you subtract it from B and C, which is multiplied together. That's how you derive your first determinant. So let me do that real quick, and I'll give us an example that we can go off of, and you can kind of see the steps that are taken in order to do that. I'm trying to make this quick, so it doesn't take up too much time. It's actually a relatively easy concept. It's just a matter of taking the time to learn it. After that, it should be pretty good. Alright, so we have two systems of equations. 3x minus y equals 7. And negative 5x plus 4 equals negative 2. I actually got this example from somewhere else. I'm just going to explain the steps and solving it. And sometimes it's easier with the visual aid. But alright, so we take our x's and put them in the first column, our y's in the second column. So we have 3, negative 1, negative 5, and 4. We now have a 2 by 2 augmented matrix. Now we're going to multiply our A and D, so it'll be our 3 and our 4. And we're going to be subtracting that from our 5 and negative 1 multiplied together. And actually that's a negative, so you'll have it in this form. The 3 your A, the 4 your D, minus your B, and times your C. So it's kind of the same thing that we went off of. Sorry about that. And that's what you'll follow. Okay, so we'll solve for the first determinant. We have 12 minus 5, which is equivalent to 7. So D will equal 7. Now, there's in order to get your dx and your dy, because you're going to have dx over your x and your dy over d, those will be your actual positional values of your x and your y. So let me solve that real quick. What you do is for your the 7 from the system of equations, the 7 and the negative 2. That is actually going to take the place of your x's in the column, and vice versa with the dy. When you solve for dy, it'll take the position of the y's in the columns. So dy, the 2 and the 4, dx, the 1 and the 3. So it'll become 7 and negative 2, and then 7 and negative 2 for when you have the dy, when you're solving for that determinant. So let me do that real quick. So we're going to have 7, negative 2, negative 1, and 4 for our dx. So we're solving for, which is going to be 4 times, it would be 28. Well, actually, let me write that. 7 times 4 minus negative 2 times negative 1, which will give us 2 minus 28, which would be 26. Will be our dx is going to be equal to 26. Our d is equal to 7. That means our resultant will be x will equal 26 over 7. That's how we get our first coordinate value. Bear with me with that. So let's see how that's written out. So we started here, 7 times 4 minus negative 2. And notice over here that we did the x values with those values. And then once we solve using that AD minus BC, we then plug it in play. And so you get 26 over 7. It's dx over d, your first determinant. Same thing applies for your dy, which will be equivalent to dy over, or your y will be equivalent to dy over y. And that is going to be your original 3 minus 5 for the x column, and then it'll be 7 minus 2 for your y column, alright? Which will be, let's see, a and negative 2 times 3 minus 7, or actually negative 5 times 7, which, you know, so you're going to have a positive 35 minus 6, which gives you, what does that give? 29? 29. So your dy will be 29. That's the resultant. Your y value for this coordinate will be 29 over 7. So this is basically to have the visual. Okay, so 3, negative 2. Notice that the 7 and negative 2 is now in the y column. Remember where we got those values from? Here. And they take the place. So that's how you solve for your y determinant. And then you put the values in place here, where the positions would be a, d, and minus b and c. Solve for it. You get the values. You get your 29. That's your dy. Then the final result will be your dy over d dx over d, which is going to be 26 over 7, 29 over 7, and that will be your answer. I gotta cut the video though because I'm kind of running on time. Got food waiting and everything. But that's the tutorial for today. Hopefully that helps. Pretty quick, and any questions just ask. I'll help you out. Alright, thanks for watching. I hope that helps.